Good morning, Science 9. Providing you with the view there of the outside. And in fact, here is an inside view of the brand new science lab. It's a pretty incredible space that they've created here. I wish you guys could be here. That's not happening just now, but going forward, hopefully you'll all end up taking some courses in here. So we're starting a new unit today, and what I want to do is to get to some notes related to the unit, and then to show you the project that I need you to start working on as soon as possible, really. So in the new unit, we're looking at matter cycles. I guess two basic pieces of vocabulary to start with. There will be matter and cycles. Matter is anything that has mass. You've just done the unit on chemistry, and so you've learned about different forms of matter and different examples of matter. We're going to look at also how that matter cycles, how different forms of matter, specifically carbon, nitrogen, oxygen, water, how they exist in living things and then in non-living things and change through the environment. They don't stay in one place forever. Molecules of water move all over the earth. They're in the sky, they're in the ground, they're in organisms, they're in the water, in the oceans. So we're going to look at that. Part of the notes for today for that first lesson is to talk a little bit about the spheres of the earth. The spheres of the earth, well, you know that a sphere is a ball. That ball that is the earth is divided, I guess, like conceptually and, well, really physically into various spheres that you can consider when you're looking at how matter cycles through our earth. The spheres in question we're looking at are these, and here's the cross-section that is talked about in the notes. So, what I've done here is I've drawn a kind of a cross-section of the earth. In the middle of the earth, as you know, is molten rock. The core is the hottest, densest part of the earth, made of solid, super hot iron. And above that is the mantle, which is also very hot. The outer layer of the earth, only the last 5 or 10 kilometers, is solid rock. So collectively, we call that part that is the outer shell, we call it the lithosphere, also called the geosphere. Now, above that, of course, we have the hydrosphere. Hydrosphere means that sphere of water. So you probably know that water covers about 75% of the Earth's surface in the form of oceans. So it has a huge effect on our climate and on the living things that exist here, and also on the lithosphere. There's interaction between all of the spheres. For example, you know that water over time will break down mountains and send them to the ocean. The air, the gaseous sphere above us and around us, you all will know by now that it's called the atmosphere. We're going to look at the atmosphere and the substances that are contained in the atmosphere for this unit. The atmosphere, the lithosphere, the geosphere, they combine to support life on Earth. That sphere of life, thin and precious, is the biosphere. Organisms of the biosphere live in the water, they live on land, they live underground, and a few of them even live in the atmosphere. Tiny organisms like bacteria, high on the currents of air. So those are the spheres that I'm talking about. A term that I'm going to drop quite a lot in this unit is this concept of an ecosystem. So an ecosystem, sorry, still getting used to the physics of working in here. An ecosystem is a place on Earth, along with all the interactions that happen within it. between organisms and between organisms in their environment. So scientists in an ecosystem might ask questions like, what is the effect of climate on this ecosystem, on changes of weather? What's the effect, like, say, of snowpack on the growth of plants? How do animals that eat other animals, predators, affect those animals? And how do the animals that eat plants affect the plants? These are all questions that scientists will ask about ecosystems, asking about how the non-living parts affect the living parts, how the living parts affect the non-living parts, and how organisms affect each other. So that term ecosystem is one I'm going to be using a fair bit. Now, I'd like you, I'm showing this video, I'm getting this video going right now on a Friday, because I'd like you to start the project as soon as possible. Now, I have uploaded the project, Ecosystem in a Bottle, into Teams. Please do check that out. The purpose of the project is for you to make your own miniature ecosystem. So your miniature ecosystem will be sealed from the external environment, but it will also include organisms that you find in it. Now, I have an example with me. I used to have an example that a student had left in my class that was 2 years old and was still going strong. This one here has been going for the course of the winter so far. It survived the entire winter, and it still looks pretty much like it did when we got it going. It's a very simple ecosystem that is mostly made from things that I found in nature, along with some non-living parts. So organisms that are most likely to be, well, really guaranteed of being successful in your mini ecosystem, your ecosystem in a jar. And by the way, I would use a larger jar than this if you can get one. Moss. Moss is an organism that, obviously it's a plant, so it can produce its own food. And if you expose your jar to light in a window, the moss is likely to grow. Below that, as you can see here, I got some aquarium gravel. This is just a substrate for the moss to grow on. To be honest with you, I'm not really sure if the gravel is doing much of anything. Crucial though, an important ingredient to your ecosystem in a bottle, ecosystem in a jar, is water. You definitely need water. What you can see right here actually is you can see little droplets of water here. It tells us that there's water inside here that is evaporating and condensing on the walls of the jar. Possibly some of that is happening because of the moss that is being so active. Your ideal ecosystem in a jar would be one that you can create, seal, and let sit in a lit situation indefinitely. There's footage, I think I gave a link for it, of a person who's got an ecosystem in a jar going. It's a fairly large one, and it's been more or less unchanged, active in his office for, I think, 50 years. If you choose wisely the things that go in your ecosystem in a jar, it will keep going for a very long time. A general tip I can give you just now is make sure that don't put too much stuff in it, especially don't put too much soil in it. Less is more. And definitely be using moss. One thing, a common mistake would be for someone to say, think, oh, I want to put plants in it, and they pluck some leaves from a plant. If you do that, then you're just getting the part of the plant, and that part eventually dies, and you end up with dead stuff. Dead stuff inside your ecosystem in a jar isn't going to work out so well. I've seen ecosystems in a jar do really well, and some not do so well. The most common complaint, the most common problem seems to be that they set it up, and the things in there don't survive. And what you see after a while is you see a kind of a bubble, I guess. You can see the lid getting pushed up a bit. To be honest with you, this means that the things inside there are creating gases that don't involve using oxygen as part of breaking down the things that are present. And as a result, I'll be blunt about it, and it ends up smelling pretty bad when you open it up. The ideal ecosystem in a jar would be one that that's not happening with, that you can look inside and see that there's living things, entire living organisms. Again, I really emphasize moss, using the water in that jar. I would be very impressed by anyone who can have tiny organisms that are in there and that survive and then just keep going. And I encourage you to put your own take on this, to make this work for you. This is a really fun project, and there's lots of resources for how to do it. My simple example here of gravel plus water plus moss can work really well, but I've seen people have things that are more elaborate than that. So, but my own take is always keep it simple, and if you got more than one jar, feel free to make more than one. You know, there's no limit on this. This is part of a project that you'll be doing a presentation for. You'll see that I put the due date well in the future. It's June 16th, so you've got about a month. That month doesn't mean you have 3 weeks and then you make your ecosystem in a jar. No, the purpose of that is for you to see how long whether this thing can survive indefinitely. So I would really like you, if you have your jar, to get out there and to do this weekend and follow those directions and get your ecosystems in a jar going, and get them follow the recommendations for the online resources you're finding. But do it as soon as possible, because the question here is not only, can you fit these things into a jar that are alive when you put them in there? The question is, can you fit these things into a jar that are wisely chosen as things that can survive in a jar with the knowledge that they probably will, given what you're providing to them, and will they then survive for upwards of a month? When you're done, obviously it's yours. Some people will choose to take it apart and look to see what survived. Other people will give a more kind of subjective story about what happened in there. This is a project that I really hope you'll enjoy, and I think that you will. That's all I have to say for now. Again, please get these projects going as soon as possible, and have a great weekend.